recording? All right, we're going to finish up our discussion of Chapter 16 today, where we're talking about random variables, expected value, and variance. So what I have here are some rules, and yeah, that screen looks maybe a little scary with all the rules. So something to keep in mind is you might want to look back at Chapter 6, revisit our discussion on shifts and rescale, because the ideas here are the same. I will show you some of these with some numbers involved, but first I just want to point out when we're adding and subtracting a constant, so just a number to the situation, we add or subtract it to the expected value, but notice it does not change the variance. So this says if you have some random variable and you add a constant, the variance stays the same. Okay, so it affects the mean or the measure of center, but not the measure of spread. If you multiply or divide by a constant, that will change both the center and the spread. So if I want to do that to a mean or an expected value, I just multiply by the constant. Watch out, this is a little strange. If we multiply by a constant, we need to square it with the variance. And I said why? That's because we'd multiply the standard deviation by that constant, but we're squaring standard deviation. Okay, think of it this way, right? We do our constant times the standard deviation, but to get to variance, I need to square my standard deviation, so I'm also going to square my constant. So that's where we get this idea. Okay, we're squaring the constant. And then if I have two random variables, and I'm going to talk about them together, to get their mean, I would simply add or subtract the means. To get the variance, I always add. I don't subtract, I always add. So this is something I would just stick in your brain. Variance, or variances, always add. Doesn't matter in the story problem if it's a subtraction problem. The means can subtract, but variances always add. Okay, and that's because if we put two random variables together, we're going to get more uncertain. Remember, variance is measuring spread, or I like to think of it as maybe uncertainty. So more uncertain, always, if we put two variables together. All right, so let's go ahead and take a look at a story problem. So we're going to talk about cars today. Suppose a used car dealer runs their autos. I didn't write this story problem. I don't know, most of us just call them cars. Through a two-stage process to get them ready to sell. The mechanical checkup costs $50 per hour and takes an average of 90 minutes with a standard deviation of 15 minutes. So notice, on average it takes 90 minutes to walk it through mechanical, make sure it's working all right. But there is a standard deviation. That means it's a variable. The amount of time it's going to take is variable. It changes. All right, then we also have an appearance prep, so we're going to make sure this car looks beautiful. We're going to wash, polish, etc. Costs $6 an hour. It takes an average of 60 minutes with a standard deviation of 5 minutes. So again, this is a variable. The amount of time it takes to make sure the car is pretty varies or changes. So the question we are being asked to figure out is what are the mean and standard deviation of the total expense, okay, so we're thinking money here, of preparing a car. All right, so total expense. In my mind, I'm thinking, well, total expense, that's going to be the expense for the mechanical part plus the expense for the appearance part. Now, the mechanical costs $50 per hour. So it costs $50 times however many hours it takes. And I'm just going to abbreviate mechanical with an M. And then the cost for the appearance, well, it costs $6 per hour, so that's $6 times however many hours it takes. So the time for the appearance. So again, the reason that I did it this way is because the time it takes, as we discussed up here in the blue and the red, the time it takes is variable. The $50 per hour or the $6 per hour is fixed. So altogether, this makes cost for the mechanical $50 per hour, and this makes cost for the appearance. So when they ask for the mean, right here, mean, actually I'll do that in maybe green. They ask for the mean. Remember, that's just an expected value. So I'm going to call the total expense, which is also a random variable, I'm going to call it x for expense. So the random value, the expected value for the total expense is going to be 50 times, well, whatever the expected value is for the time on the mechanical, plus $6 times, well, whatever the expected value is for time on the appearance. So I can just go back and find those in my story problem. Well, it said, on average, remember expected value is simply an average, it's going to take 90 minutes for the mechanical. Well, I have $50 per hour, so it would be nice if I changed this 90 minutes to 1.5 hours. Plus $6 times, well, what's the average amount of time for the appearance? 60 minutes, so that's 1 hour. And I just type those things in my calculator, and I get 81. Now remember, we're talking about an expense or a cost, so this is $81. $81. So on average, it's going to take $81 to get a car ready to go. Now we are not quite done. We also need to do the standard deviation. Now, none of my formulas are about standard deviation. They're all about variance. So I'm going to do my story problem first in variance. All right, so I'm going to be looking for the variance of my total expense. Now I can follow kind of the same pattern. It's going to be 50 squared times the variance for the amount of time it takes to complete the mechanical. Wait, why did I do squared? Because of right here. We multiply or divide by a constant. It's got to be squared with our variance. All right, and then I'm going to add 6 squared times the variance for the appearance. Now, I've got to go through and figure out, well, what goes here and what goes here. All right, so it's going to be 50 squared times, well, what's the variance for the mechanical? Remember, we're in hours. So up here when it said there's a standard deviation of 15 minutes, ooh, 15 minutes. That's 15 out of 60 minutes to make that into hours. Okay. And that's a standard deviation, but my formula asks for variance. So I'm going to have to square that to make it a variance. Okay, and I don't mind fractions, so I'll just leave it as a fraction. If you want to reduce that, it's 1/4. Plus, I'm going to do 6 squared, and I need the variance for the appearance. So again, if I revisit my story problem, we had a standard deviation of 5 minutes. Well, 5 out of 60 gets me into hours, but that was standard deviation, so I would need to square it to get a variance. All right, so if I plug those in my calculator, I get something nice, or not so nice, like 156.5. I would definitely pause and make sure you can successfully transfer that into your calculator. But remember, the question did not ask for the variance. The question asked for the standard deviation. So we need to remember the relationship between standard deviation and variance. Remember, standard deviation squared is variance. So if I have variance, I need to square root to get me the standard deviation. So I'll take the square root of that 156.5, and that gives me approximately, in my calculator, 12.51. And remember, we're still talking about a cost, so this would be in dollars. All right, let's go ahead and take a look at 2 more problems with this same story. The question asks, what are the mean and standard deviation of the difference in cost? Ooh, difference in cost. That's a subtraction problem for the 2 phases of the operation. So if I'm thinking of difference in cost, well, that's a subtraction problem. I know that the mechanical takes $50 per hour times the amount of time in mechanical. and it's $6 per hour for appearance. And again, if I want the difference, I'm just subtracting. So if I want the mean, or the expected value for this difference, I would take 50 and multiply that by the expected value for the mechanical, and I subtract 6 times the expected value for the appearance. Hopefully you're noticing this is really similar to the problem we just did. The only difference is I'm subtracting instead of adding. That is the only difference. So I do that and I get $69. All right, so then we would move on to the standard deviation. But remember, we can't start with standard deviation. We have to start with variance. And I would be setting up my problem. Oh, remember, it's squared the same way. Here's where we run into one small problem. Remember, I said variances always add. So this one, even though I'm talking about a difference, and we have a minus sign in our situation, this one is still a plus. Variances always add. So hopefully at this point you would notice this problem right here looks exactly like the one we just did. So I could actually skip to the end. I know my standard deviation is 12.51. Kind of cool. So the amount of variance, or standard deviation, the amount of spread is the same because variances always add. All right, just to finish us off today, same story problem. We're going to actually work through this one in class. It says, suppose both processes, so I'm talking mechanical and the appearance, can be described by a normal model. Okay, don't let that worry you right now. We'll come to that in class. But we're going to be looking at the probability it will take longer to do the appearance prep than the mechanical checkup. So longer, we're going to be talking strictly about time. We're going to leave the money part out of it. So to help us get ready for this example in class, what I'm going to ask you to do is figure out both the mean and the standard deviation for the difference in time, right? Because we're talking about longer. So we'd be doing a difference in time. So difference in time means we're going to take the time to do the mechanical, and we're going to subtract, because we want a difference, the time for the appearance. I'll actually help you get started on the mean, or the expected value. I'm going to call this T for time. I would just take the expected value for the time it takes to do mechanical, and I would subtract the expected value for the time it takes to do the appearance. So we read above, it takes about 1.5 hours to do the mechanical, minus it takes 1 hour on average to do the appearance. So we have an expected value of 0.5, and this is in hours. You can actually do this story problem in minutes, and it will work out just fine. So your task is to do the variance for the time. Remember, variance is always add. And when you get your answer, be sure to take the square root, so you can also have a standard deviation.